question for the IR, we talked about using those intense band, to figure out, what molecule that could be responsible for the spectra. So we got here alcohol, we have a ketone, we have a carboxylic acid, amine, and secondary amine, and then nitrile there. So you're gonna, even though we provide a table of the weight numbers for the functional groups, you still need to know how to use them. So you're gonna still anticipate what you're gonna see for each of the molecule as a major signal. If you have an OH groups there, I told you the OH groups going to be really broad, intense signal, and 3,300 weight numbers, right? And then it is a ketone like the carbonyl. Carbonyl is very polar functional groups. It shows a strong signal that's around 1710. That's a typical number for the carbonyl. Carboxylic acid is also show the 1710 signal, but these ones are conjugate next to the double bond. So what is placing double bond next to the carbonyl, it will bring it down because of the resonance structures. So around 20 to 30, so I'm expecting the carbonyl of this molecule is not going to be 1710 anymore. It's going to be probably 1680, 1690, around that range. On top of that, this OH is going to be really broad signal like this. Center 3000 that's basically that huge deep valley. Center 3000. That is a very characteristic of carboxylic acid. And obviously, we have the carbonyl stretching signal go down right there. But you can see that that's kind of a below, a little below, like around the 1700 to me. So that currently, that is an indication of this conjugation, bring it down to the carbonyl signal lower than 1710. So this spectrum A is definitely, makes sense with these structures. But continuing in the example, we got amine. NH signal is going to be small, but it's around 3,300, that's where it's going to show up. Since there's only one NH bond, there's going to be one spike, single spike, instead of two. And then if you got the C-N triple bond, it's for the nitrile, that should give us, very characteristic band at the 2200. So that's something that we should look for. So for this spectrum A, we think that's what it is because of these huge OH signal center at 3000, and also the lower, carbonyl stretching, and that makes sense with these structures. But the next one, for instance, this one, what we should look for is actually start with the strongest one, that signal is pretty strong. That's about the 1710. It's a very standard number for the carbonyl. So we already exclude that one out. So only thing that has a carbonyl is this one. So it's pretty easy for this question here. But ketone actually don't have anything else to look for, unfortunately. You see the carbonyl, but there's nothing else going to show up. This molecule don't even have any unsaturation. So if you look at the 3000 line, there's no unsaturated carbon-hydrogen band there at all, right? You got nothing else showing up in anywhere in the molecule and spectrum. Only thing that maybe you're gonna be questioning is that maybe that small spike at the 3400. Is it significant? That's the question you're gonna ask, because that may be accounting for that might be confused. Maybe this one may be related to that signals. But if this one to be this one, then you're gonna see the benzene. So you should have some unsaturation band. At the same time, if you got a benzene, I told you that there's a signal, even if it's small, you may be able to see the 1600. And the 1600, I don't see anything. So that means that there's no benzene there, right? And then what is that 3400 signal then? That is an overturn of this carbonyl. When you have such a strong, intense signal, sometimes the first harmonic shows up as a visible amount. So that is this. So if you have that together with the carbonyl, you gotta suspect that it might not be the real one. It may be just the first carbonyl of that carbonyl structure. All right, what's going on? Okay, so that is related to that. All right, moving on. This one, which one is the most characteristic signal in this spectrum, which I want you to recognize right away, is this one. There is a normally flat line here, between 2000 and 2500, nothing really showing up unless you are triple bonds. So having the signal there, that is definitely the most important signal. You should pick it up. And then there's a 2200, and it's pretty strong, right? So I would consider this kind of nitrile. If it's a carbon triple bond, first of all, intensity is weaker than that typically. I'm talking about typically, there might be exception. At the same time, it's not the 2200, typically 2100. I mean, you can move around, but it's going to be lower than that. That's my guess. Anyway, so in here, that's the only one with an alkyne. So let's make sure that this, I would have nitrile, and let's make sure that this is the spectrum for that molecule. Because in the molecule structures, we have a benzene. So do we have a 1600 signals? And yes, we do, right? So we do have a benzene there. And because of the benzene, we got the unsaturated carbon hydrogen stretching signal, which will show up a little above the 3000 line. So you can see that there's that band is higher than 3000. That's the one that coming from the hydrogen of the double bonds. And that molecule have a no carbonyl, so we don't have an absence of that signal there right there. Otherwise, it would be pretty strong if this molecule is a carbonyl. So all these things checks out. So I think this spectrum is for that one. And the last one, what is the first thing you could look at is that one, right? This is 3400. We got a pretty, moderate intensity signal band right there. And that's a little too high to like a 3300, but as I said, this number can change depending on how much hydrogen bonding they makes it. So we got a candidate for amine, hydroxyl groups, maybe triple bonded for carbon hydrogen stretching, but we don't have this one, so we can eliminate it out. Typically, the alcohol makes a more bigger and broad signal than that. So that is kind of a characteristic for the secondary amine, right? Like that one. But obviously, if it's this one, we should see the carbon hydrogen signal showing at 2100. I don't see anything. So we should eliminate that possibility too. Between this and that, I mean, some of the alcohol may show a sharp band like that, maybe a little bigger, but just in case we are considering these two, what is the secondary evidence to sort them out is having the unsaturation. This is a fully saturated molecule, right? There's a benzene, 1600 signal right there. At the same time, this double bonded carbon and hydrogen stretching is right here. So this molecule is probably going to amine with the unsaturated carbons available. On the other hand, the former example right there is a hydroxyl groups with everything saturated. So don't just look at the one evidence to sort them out. Try to look at the secondary evidence to corroborate your idea to be confirmed. So that is basically my suggestion to do the ion related questions.